In preparation for today's session, please make sure your tray tables and seat backs are in the upright and locked position. Tim will shortly be demonstrating the safety features of Auditorium B.
Exit to the right, exit stage left. Exit on the left.
If the oxygen masks drop in front of you, exit, exit, run like hell.
At the party tonight.
There is to be no consumption of alcoholic beverages in this room unless you have enough to share with everyone.
Including the presenters.
Especially starting with the presenters.
And the first presenter is most important.
Indeed.
Push the button. Tick-tock.
Good afternoon. How are you? Have you been enjoying Tech Ed? How much? You know, at Microsoft, we do not release software until we've been using it for a long time ourselves, right? Before it goes into beta, we use it. We call it eating our own dog food. And apparently, the culture of eating our own dog food extends here to Tech Ed, where it has taken over the dining area. The real Microsoft dog food experience. Where's that evaluation?
We're done. Hey!
All right. The food was not our fault, so you can give us all top marks. This is the sysinternals primer, the Windows sysinternals primer. We're going to be talking about Process Explorer, Process Monitor, and PSExec is actually the third one. Now, many of you in this room are looking up here and thinking, wait, which one is Mark Russinovich? And those of you who can read are realizing, wait, that's not Mark Russinovich. Where's Mark? I came here because I wanted to see the greatest speaker Microsoft has. I wanted to get my picture taken with him afterwards and touch the hem of his garment. He's here. He's got a session. His most popular session, I believe, is coming up.
5:30,
last session.
Yeah, last one of the day.
Case of the Unexplained, and you can go to that and get his autograph. And if you're very nice to him, he will let you kiss his ring. So,
and if you bring him something, you might even give it a hug.
Even.
Maybe.
So, those of you who are wondering, many of you are wondering, well, who is that talking then? And the rest of you are saying, oh, no, it's Aaron. So, I'm a principal consultant with Public Sector Services, U.S. Federal. I work primarily with federal government customers. Tim here is a technical account manager, senior technical account manager. You can tell by the gray hairs. With Microsoft Services. And we spend a lot of time with sysinternals tools. And what else to say about it? Well, there's this, too. The Windows Sysinternals Administrator's Reference, which if you go up to Amazon.com right now, you can see this book up there. It probably says it's already been released, co-written by Wes Miller, except that Wes went insane and couldn't finish it. So it's a book now that I am working on. And you can tell from the proportional size of the fonts exactly what the proportion of work is. And it's basically, I write all the words in the book, and Mark stands over me with a bullwhip saying, faster, boy, faster. So hopefully get that released real soon now. So what we're going to do here is we're going to talk somewhat, give an overview about sysinternals, very briefly, hopefully. Then we're going to talk about Process Explorer, Process Monitor, and then PSExec. The reason the title said "and more" is because when the deadline came for submitting session ideas, we hadn't really determined what the rest of it was going to be, and we finally decided to do PSExec. So how many of you are familiar with sysinternals? I can't see over the lights. You'll have to applaud really loudly. that feel better? Gets your blood moving and stuff? Okay. Sysinternals. Microsoft acquired WinTernals and Sysinternals back in 2006. We brought in Mark Russinovich and Bryce Cogswell. WinTernals is where they made a lot of for sale tools. Many of those, or a number of those, are now part of MDOP, the Microsoft Desktop Optimization Pack. Sysinternals were free utilities that they made available to the entire world. They're high-quality, advanced diagnostic and troubleshooting tools. One really cool thing about them is they come in a single executable package. Even if they need additional DLLs or drivers or 64-bit versions and things like that, you run the one program and it self-extracts the other pieces that it needs into the file system and then uses them. So you don't need any installation. You just run the tool. They're all free. They're all authored by Mark or Bryce. Another aspect of the Sysinternals tools is the quick turnaround and update cycle. They don't have to go through program management and product design and LCA and stuff. They come up with a new tool or a new version. They post it to the web. If it works on Mark's machine, it's up on the web the next day. That's not entirely
Quite true, but it's close.
Has to work on Bryce's machine, too. Of course, they run with UAC disabled all the time, so, you know. No, they don't. No, they don't. I'm sorry. Limited support. These tools are as is. You can't get a escalation through Premiere or CSS. These are supported as is, best effort, because it's all volunteer work. Some features of the website. You go to sysinternals.com. It redirects you now to technet.microsoft.com, takes you to the web page where you can find all the stuff. One really cool thing that happened after the acquisition is they finally took all the tools and packaged them in one zip file. You can download them individually, but you can now download the entire Sysinternals suite. Dozens and dozens of tools, one zip file, one download, and you can keep that up to date. The site blog, you should subscribe to the site blog and get announcements whenever anything is updated on the site. You can run tools directly from the web using Sysinternals Live. Okay, just use these URLs or UNC paths, and you can run the latest version of the tool without having to make sure to download it first. One thing about that UNC syntax, the web client service has to be running in order to use that, and that's not necessarily on by default. The website also has videos on troubleshooting with the tools. You can see Mark at previous conferences demonstrating a variety of tools and troubleshooting techniques. Okay, so how many of you have downloaded Sysinternals utilities and seen this dialog every time you run the tool? By applause, please. Yeah. How many of you have seen this? You download the tools, you try to open up one of the help files, and you get this. The solution, or the problem actually, is that when you download something from the internet using Internet Explorer, it gets tagged with metadata in an alternate data stream that says what security zone, what IE security zone it came from. And then even though you're running it from your local file system, Windows remembers this came from the internet, treat it like it came from the internet. So what you need to do is to remove that zone information. The easiest way is before you extract from the zip file, click on the unblock button on the zip file to remove the alternate data stream. Another way to do it using, yes, a Sysinternals utility called Streams. Streams will tell you what alternate data streams exist in these files. The zone identifier stream is the one that contains that, the security zone information. Streams-D removes, did someone's phone ring?
It's for you.
We said before the flight began, no electronic devices. Streams-D removes alternate data streams, and so you can use that to remove that zone information. So with that, I'm going to turn it over to Tim and go into Process Explorer.
Thank you very much. So one of the things as I was trying to figure out how to best present this session is to take somebody that may not have used Process Explorer before introduce them to the tool, and then rapidly progress it over 25 minutes to a level in which those who have used it, and there were quite a few of you by the show of applause that have, and then rapidly progress into the deeper side of it. So if you're totally bored for the first 5 minutes, hang in there. It will rapidly increase in pace.
There's one thing I wanted to ask ahead of time. How many of you have how many of you are here because you don't really feel comfortable or strong using the sysinternals utilities and you want to get the basics of how do I run these tools? By applause, how many of you? And how many of you already spend more time in Process Monitor than you do with your own families? We've got a mix. What we're going to try to do, like Tim said, is hopefully have something for all of you. The basics for people who need to understand the basics, and some tips and tricks, hopefully, for people who want to learn more.
Absolutely. All right, so let's get going. And I have, I think, a whopping 2 slides, unless anybody wants more than that. Anybody want more than 2 slides? There might be 3. So this is the quick rundown of what we're going to talk about here. And since we're going to talk about Process Explorer and Process Monitor, I thought it might be a good idea to level set everybody as to what exactly a process is. We'll talk about some of the good and the bad and the ugly of Task Manager, and I think my last slide that I normally had in there is not in there, but that's okay. We'll also talk very briefly about some of the good things and the gaps that were in Task Manager that Mark then decided to develop and put into Process Explorer, and a whole lot of demos. So, what's a process? It's a container for a set of resources, including 1 or more threads. And an important point, it's the threads that actually do the work. And for every process that you have to have at least 1 thread. So when a process is spiraling out of control, you might have, say, Notepad, if it happens to spiral out of control. There's a thread inside of there that is the one that's actually doing all the work and consuming all of your CPU. I'm a very visual person, and so this helped me kind of wrap my brain around this. The green and yellow box there is my process, or my container. And inside of it, I can have all of these different things. 1 or more threads, virtual memory address space, security tokens, handles, etc. So, Task Manager, everybody's used it. Your mom uses it, your dad uses it. My boss uses it because it's a very rudimentary tool for a quick killing of a task. What is a task anyway?
Yeah, task, that comes from Windows 3 and earlier.
Yeah.
It's 16-bit Windows where that comes from.
I wonder if they'll change that eventually, but maybe not. And so some of the things that you miss out on in Task Manager is you don't see fractional CPU. So if you have a CPU cycle that's going at 0.7, it'll show a 0. So it doesn't have any decimal points in there, which is something obviously that Process Explorer takes care of. Other things is that it doesn't show threads. So you're not able to determine, you have a process and it might show at 56%, but what the thread, as I said earlier, is doing the work. So what thread is the one that's causing all the work to be done? And so here we have some of the things that have been changed or that were added. There were gaps in the Task Manager tool that Mark thought would be good to fill and wanted to have a parent-child relationship, wanted to be able to peer into different processes, wanted to give you some options that you would be able to customize and save, export out of a registry, import back into your HKey current user, etc. And with that, I will push the button, or you will push the button for me. I'll hand you that back. Turtle. So this is my machine. I love the Bing's Best wallpaper, and so that's why the turtle is there, and it may turn over here even as I go. But I want to start off just by showing when my machine starts, it always starts Process Explorer through the Startup menu. And not only do I have in the Startup menu Process Explorer sitting, but I also have a couple of switches with it. And I've got the /T and the /E. The /T tells Process Explorer to start but be minimized, and then the /E is to be elevated upon launching. And the reason why I want it elevated while launching is that I want to be able to see in all the details of Process Explorer, I want to be able to see the details for all the different processes that are running. And obviously if it's not elevated, that's not going to happen. So this is a fresh, off-the-deck version of Process Explorer, released 48 hours ago. And so it'll run the EULA I'll get the UAC prompt, and then you'll see it'll appear down here in my lower right-hand corner, where basically it will be very quiet for a very long period of time until something bizarre happens, and then I want to jump into it, CPU performance, sluggishness, whatever, and then I'll double-click that thing and open it up and get started. Let me make this bigger. So as a general UI, the one thing that you'll notice here, as I talked about, you get your parent-child relationship that's here. And then one of the first things that I actually like to do is configure some of the options that are here. So I like to hide it when minimized, so when it's not using, if I hit the X, it'll just minimize into the lower right-hand corner, sit there quietly doing its thing. I like to allow only one instance of it. And so occasionally when I was first learning this thing, I would click on Process Explorer all the time and ended up with like 20 different ones in the lower right-hand corner in the tray. So I figured that that would be a good thing for me to do, since I have a tendency to not remember what I've been running on my machine. I do the difference highlight duration, and so this here is the default, and it's 1 second. I like to change it so it ends up being 5 seconds, and that comes in handy especially for processes that are starting, which will be flagged as green, and processes that are exiting, which would be red. The other one that is important to do is to configure your symbols out of the gate. And the reason why this is important is that if you open up something like Notepad and you click on the Threads tab, you're going to get an error message saying that the version of DBG Help that's included with Windows is not good enough. And so you need to go out to the internet, download the Windows debugging tools, and then correctly put in the location that you have installed it, along with a path to the Microsoft symbol server. And so one last thing. If you don't do that, then you get this hexadecimal gobbledygook technical term that will change, and I'll show how that changes after we get it populated with what it needs to be. So here we'll come into symbols. I've got my symbols installed here. And then the symbol path. And all of this is in the slide deck, so please don't think that you have to write it down. We have what do we call it? It's like at the end of the deck, we've got a bunch of extra slides of things that are applicable to both Process Explorer and Process Monitor. And so here I've got everything configured now with the symbols path, and also where my dbghelp.dll is from the Windows debugging tools. And once I click OK on that, we will bring this over. We'll come back to our Notepad so you can see what changes. And here you'll now see that there's actually some useful information there as opposed to the hexadecimal gobbledygook. So, a couple other things that appear that sometimes people wonder about is you have some pseudo processes. And so there are things that run on the system that show up in Process Explorer, the interrupts and the DPCs. And these are basically the amount of CPU time that are given toward your hardware interrupts and your deferred procedural calls. This can come in handy for those of you who deal with servers on a regular basis. Sometimes if you have a bad device driver, you'll see that there's a CPU usage that's fairly high in the interrupt side, and you want to go potentially out to whatever OEM manufacturer you have in your data center and look at downloading a new driver so it's not consuming as many hardware interrupts. So that is something that you can look for as you get that infamous call of my server is slow. That's something that you can keep an eye out for. The process highlighting, so this is another feature that is obviously not in Task Manager. The pink here is represented by, let me zoom this in here. So you got your pink, which is represented by all of your, any process that contains one or more Win32 services. Your processes that represent or that are using the .NET framework are yellow, and then the light blue processes are processes that are running the same user account as Process Explorer. The other ones that haven't appeared yet are the red and the green, which I mentioned earlier, and that is for things that start. And so let me fire up a command window, and we'll get this out of the way. And there's the green from the command window that I started. And if I was to exit out of it, you'll see that it will turn red. It'll count for 5 seconds, and then it'll disappear. One quick note of the parent-child relationship with that is shown inside of Process Explorer. Here you can see that we have a command window, and that process then spun off by me typing in notepad.exe. Notepad fired up, and each one of these is given a process identification number. So the command window had 5456, the notepad had 2620. So then the question is, well, what happens when the command window goes away? Well, let's go find out. So let's kill this command window. And you'll see here the command window is now in red. It's closing. The notepad will actually left center and appear at the bottom of the list, still with this process ID of 2620. And if we look inside of it then, there's also a brief history inside of the image tab of what process or what the parent process was at the time that Notepad started. And it also tell you the user that's here and what time that was actually started. So I was trying to think about, well, where would this be useful for an IT pro inside of a data center? I know that my customer has sometimes their security group will run random scripts that will cause help desk tickets to be generated, and then they get on call duty. And it would be nice to know who kicked off that script. And this might be an opportunity to at least start down that road of determining who and what was the root cause of that. And they can go after them and go, why did you have my pager go off by launching this script? All right. Let's see. A couple other things that are just kind of in the GUI is the hover, as we talked about. In Task Manager, you have a laundry list of service host .exes that will appear in a flat list. So here are all the different service host .exes that appear in my flat list. There's really no determining, though, what each one is doing. And so with Process Explorer, you can hover over top of each one of them. Let me find my network service. And now by hovering over top of it, not only do you get the full path to the executable, but you get all of the Win32 services that are running inside of it. All right. Time check. How am I doing? Good. All right. So one other thing, we'll talk about the toolbar here a little bit. So here we have the Find Windows process, and with this, you can find any window that is running on your machine and determine what process identification it is. So if you click and hold, it'll bring forward into the forefront, and you take that magnifier and you can see how it kind of highlights all the different things that are here. And if I drop it onto, say, this Notepad window, it will automatically snap down and then show that what you hovered over top of, it'll give you the PID of what it is. So if I had multiple Notepad windows over it, each one of those Notepad windows has a different process ID associated with it, and I would be able to drop that little magnifying glass on top of it and instantaneously know which PID I was dealing with. And this was an interesting demo that Aaron here gave me, and it shows that if you were to hover on top of the GUI hang demo, it will go to the GUI hang.exe as it's supposed to. However, if you were to actually run, see, I did it. You're not supposed to hit escape, you're supposed to hit A. If you were to run the hang demo and wait for it to not respond, and then drag your Find Windows process on top of it, it goes to the DWM.exe. And the reason for that is that in Windows 7 and Windows Vista, you have a new way in which the screen is actually, or the visual that you're seeing on the screen is rendered. It's not in XP in 2003, it's rendered directly to the screen, but with Vista and Win 7, it's actually rendered into video memory, and then from there, it's rendered back out to the screen. And so, excuse me, DWM recognizes that that process is hung, and if you think about it like layers, you have the visual of when a process is not hung of the window, but when it gets hung, the DWM takes over because it has an image that's stored in memory, places it on top of it so that you can still see that window and then drag it around without getting, if you remember in the XP 2003 days, get the white screen that would appear. And so that's why when you have a hung window and click on the Windows process, you get to see the DWM show there. Let's get into some of the columns that you can that you can set here as well. How many of you have a tendency to play help desk for mom and dad? Show of applause. Everybody? So, and how many of you typically think, oh, mom, dad, why did you click on that link saying that you didn't have a firewall installed? Or you didn't have antivirus installed? And so one of the things that you can do is you can pop open a column here that's verified signer. And what this does then is it tells you if that process has still been digitally verified and hasn't been basically messed with since it left the publisher. So we'll click on that, and it's blank. Rats. There's a reason for that, and that is in the options, you have to have your verify image signatures selected, and as soon as I do that, you will see that it will populate, and it'll verify all the different processes that are running. And so for those of you who run over to mom and dad's house because the machine's sluggish and they clicked on something they should have, but yet you run your antivirus and it shows clean, but it's still sluggish, you might want to check the verified signer to see if everything is truly verified on that machine. As I stated, everything here that you do is customizable and savable in a registry, and so I've got a couple other things that I will work with columns, but instead of you guys watching me do them all individually, I will import quickly all of the settings from the registry and then restart Process Explorer. So I've set 3 different columns, or column sets. I have set up Tim's default, which is basically what you're looking at here, and then I've got a threads column and a CPU column. So let's hit over to the threads column. And what this view does for me is that for every process, it shows me how many threads are actually running inside of that process. All right, so in this instance here, this service host has 85 different threads that are running inside of it. Explorer.exe has 33. Etc. There was an interesting, where this comes in handy. There was an interesting case that was opened up with our Premier Support Services. We had a third party that kept having their application crash. And because it kept crashing, my customer said, we need your help to identify what is causing this thing to crash. So we got Premier Support Services involved. They went through a bunch of dumps. They determined that at the end of the day, what was going on is that there were not just maybe 16 processes running inside, or threads running inside the process. There weren't 160 even. There were 1,600 plus processes or threads that were running inside that process. This was a 32-bit system, 32-bit processes, and the max amount you can have theoretically is 2,048 threads. And so having 1,600 plus threads was what was collapsing that. And so we went to Oracle, and told them. I said that out loud, didn't I?
Mostly we don't mention vendor names.
Sorry.
Mostly.
Sorry. Mostly.
Unless they do something really bad.
Like 1,600 plus threads in a process?
Yeah.
Yeah, okay. So we ultimately presented them back the data, and we said, here, you guys need to go deal with this because this is not a best practice of how to run an application. So let us get out of that and jump into the next series of columns. CPU is always a fun one. Everybody wants to know what CPU is doing. The interesting part about CPU is as you look at the numbers flash across the screen here, we only go to 2 digits, right? So it could be 1.75, 0.74. What about the things that are under 0.01? Where do they appear? Well, they don't appear in the CPU column. And so let me pause this, and we'll come up and we'll take a look. So here we have, for instance, we have the Zoom It tool, which is the cool sysinternals utility that I'm using so that we can zoom in on this stuff. It used, since the last refresh, which is happening every 1 second, it used 2.22% CPU time. But here we have Internet Explorer, which shows up as 0. But that's not really true. There's a lot of work being done in between that 1 second clock that's running there. In this case, the context switch had run 79 times. And this is where Windows schedules a thread to run. And then it had been scheduled to run 79 times. And if you look over at the cycles then is the amount of cycles that thread used on the processor itself. The delta then is the piece that runs in between every second. And so if you really want to get a good view as to what happened during that last second with regards to your process, the context switch delta and the cycles delta are an excellent way to look at that. And so again, try to put some context into real world. Where would this come in handy? If you've got a laptop that seems to be draining battery life, and the OEM told you it should be 8 hours, and you load up all of your in-house tools on top of it, and you only get 3 hours of battery life, it's very possible that a lot of the processes that are on there are running underneath the radar. They're not consuming CPU as far as the visual of what you can see with Task Manager or even Process Explorer. But if you've got a lot of C-switch deltas that are run there, you might want to figure out what that process is and try to correct that. We have a hidden pane here that we haven't even talked about yet, and this is the lower pane window. And the lower pane window will show you the DLL view you have. You have the DLL view and the handle view. And so if we come down to my notepad window that I've got going here, the DLL view shows you all the different DLLs that are associated with that process that I've selected. So in this case, all these DLLs are associated with the notepad.exe. And the same thing is true if I come in and I hit Control-H on the keyboard. That gives me the handle view. I still have my notepad.exe. And here you can see all the different handles that are associated with my notepad.exe. And so real world context again, I have a Word document here that's open, and it's a very simple example, but you might log into a server and you need to delete some kind of an application or a document that exists there, and you hit delete, and of course you get the wonderful message, can't delete it because something's attached to this thing and using it. Process Explorer is a fantastic way to determine what process is attached to that document or that article that you want to try to delete. And so we can hit Control-F on your keyboard, and we will type delete. We'll wait for Process Explorer to do its thing, and it will quickly determine that it went away. The process that has a handle open to that file that I'm wanting to delete is listed here, along with the PID number and the exact path to that document. Last thing before I kick it back over to Mr. Margosas is I want to talk a little bit about some of the graphs that you see. Here at the top, this is all the CPU that's running. You got red and green. The red is all of your kernel usage as it pertains to the CPU. And then the green is a combination of kernel and user. So you have to look at it in its entirety. This graph, as it is, it does not distinguish between CPUs. So I've got a dual core box. I've got 2 cores, and it's aggregating them. So if I had 100% of CPU being used on one CPU but not the other, it would actually render as 50%. Unless you happen to crack the system information open and then click on the show one graph per CPU, and then it will split that out. So let's do a demo with a little utility that I have. So a utility called Processor Hog, and its sole intention in life is to spin up a bunch of threads that will consume my processor. So I'll add 4 different threads. You'll see that my processor now jumps. Let's get rid of the lower pane view to tree. And here's my processor hog.exe. And you can see that it's consuming almost every ounce of processing power that the machine has. If we go into the graph, though, remember what I said. This is a 2-proc box leveraging 100%. But if all of the threads were assigned to one processor, it would dump to 50%. And how you do that is by setting the affinity, and I can now assign that one process or to a specific CPU. And you will see now the graph switch down to 50%. And if I open up the other view that I had earlier, you can see here that CPU 0 is still continuing to use 100% of its CPU, and the CPU 1 is now using 0. And so where this can come in handy is you log into a server, a desktop, CPU is spinning. You can set the affinity to one processor so that you have CPU cycles to be able to do some work as opposed to sitting there being frustrated and banging your hand on the keyboard going, it's killing me to wait this long to try to get anything done. The other things that you can do to help with this is you can actually suspend the process altogether. Be careful with this, because if you have users that are attached to that process, it's also going to kick them out of it. You can also kill the process straight away, which is the same thing as the old school end task with Task Manager. And then you can also create a dump, both a mini dump and a full dump, so that if this was an in-house application that was spinning out of control, you could present that back to a developer. They never screw up, though, do they? And say, hey, if this was going on, would you please help me evaluate what's going on inside of this process at the time that it was spinning out of control. So that is all that I have. Hopefully for those of you who have used the tool, got a couple of tips and tricks out of this, out of my 25 minutes or so, and hopefully for those of you who are new, feel comfortable enough to fire into it. And with that, I'll turn it over to Mr. Margosis.
Okay, thank you, Tim. So that's Process Explorer. Next, we're going to talk about Process Monitor. So some people get these two tools confused. They think they can use Process Explorer to track things, and they're completely different tools. Process Explorer shows you basically a moving snapshot of a system at a given point in time. Process Monitor is a logging utility that allows you to capture all the activity on a system, at least with registry, file system, network activity, and so forth. And also process and thread events, including new threads being started, new processes being started, threads exiting, DLLs being loaded into a process image. It also will pick up periodically profiling data and tell you what the accumulated CPU cycles are and other statistics like that per process. Some cool things: you can save the results of these traces and then send them to someone else to look at them or analyze them at a later time. You can log boot activity. This is really vital because Process Monitor is primarily a GUI tool, which means you have to log in before you can run it. What if you want to trace what's happening at the beginning of a boot up cycle or as someone is logging in? Process Monitor allows you to log boot activity and capture all that information. The filtering capabilities are tremendous. You have very, very flexible filtering, which I'll be demonstrating. And there's some analysis tools for data mining. You can analyze the entire trace and find all the registry keys in one summary report that were accessed. It's command line scriptable, which can be very useful if you want to have someone else who is not familiar with the tool go ahead and run it so that they can send you a report. I've got a demo of that coming up as well. How many of you have heard of FileMon or RegMon? By applause. Those tools were created a long time ago, and they really put sysinternals on the map. They each analyze. RegMon would analyze registry activity, FileMon file activity. How many of you are still using those tools? By applause. Why? Are you still? Oh, Itanium? Is Procmon? There's no Itanium version of Procmon. I forgot about that. Okay. For those of you still running Windows 98, Process or FileMon and RegMon are still there. FileMon and RegMon have been retired. They're no longer available on the website. The idea with Process Monitor is that it would, can you run RegMon and FileMon on an Itanium? It doesn't install drivers? Did you make Itanium versions of it? Okay. I don't have an Itanium laptop, so I don't ever get to try that out. FileMon and RegMon had some severe limitations, all of which are, aside from the Itanium issue, all of which have been overcome. And it can capture far more data without bogging down the system. It gives you much better filtering capabilities and so forth. So this is a screenshot of Process Monitor in action. For every single event, you get a time of day when that happened, the name of the process ID, the type of operation it was, what path in the file system of the registry was involved, the result of that operation, and additional detail. And then you can open up the properties for any of those things and see far more information than you can see in the list view. The event tab will show you a lot of what's on there, as well as open up the details. For example, this particular operation is opening up a path in the file system requesting read data, list directory permissions, read attributes, and some others. Whether it'll also tell you whether the file was created or was opened, whether it was newly created or just an existing one was opened, what the share mode was, etc. The process tab will show you at that moment in time when that particular event occurred, what was the state of that process with regards to what DLLs were actually loaded into the process at that time, including the full path to the DLL. It'll show you whether it's a 64 or 32-bit application, whether user account control file and registry virtualization is enabled for it, and is in effect what the integrity level is, meaning is it running elevated or is standard user or low, and other things like that. The stack is vitally important for certain types of diagnostics. This tells you at the point when this operation happened, what is the trail of breadcrumbs within the program that led to that point? Okay, something in IE frame in this example called something in shell 32, which called internally to other things inside shell 32, which eventually called to the create file API in kernel 32, which called the NTDLL native API, which then made the transition into kernel mode, and that's where you see it go from the U. The stack goes from the bottom to the top. Okay, so it transitions from user mode to kernel mode, at which point eventually process monitor will capture that information. Anybody want to see any more slides, or you want me to just go ahead and demo? Okay. So the way I set up my system is I download the zip file, I remove the security zone information, and I copy all the utilities into program files sysinternals. And then I add that to my path. So then I can access the tools anytime I need from anywhere. So I'm going to run process monitor, procmon. It always requires elevation unless you're opening an existing log file. Process Explorer will run as standard user. It won't tell you nearly as much information as if you do when you run it elevated. But process monitor, because it's capturing that information by loading a driver into the kernel, it requires elevation in order to do that. And right away, it's capturing information just in the couple seconds here. Over 60,000 events have been captured already. There's a lot of stuff going on in the system. So let me give it something interesting to look at. OK, I've run into a bug in my program. So let's see if we can figure out what's going on here. So now that I've reproduced the error that I want to diagnose, I'm going to stop the trace because I don't need to capture any more data at this point. And I've got 70,929 events to go through, and I can go through them one at a time and figure out what's going on, or I can filter things down. Now, by default, it's already filtered it down to about 32,000. There's only 32,000 events, which makes it much easier to deal with. I can finish that in a day or two, right? Well, let's filter that down a little bit more. So some ways you can filter events. You can see here that you've got file system events with the old file manager type icon there, registry events with a registry looking icon, some network events belonging to different processes. It shows you the icon of the executable image if there is one. I can filter out all the registry activity just by clicking this toolbar button right here, show registry activity, and it hides all the registry activity from the view, showing me only the other events remaining. One of the big differences between this and FileMon and Regmon is if I did that in FileMon or Regmon and filtered out activity, I couldn't get it back unless I had previously saved it to a file. But here, I can click that button again and bring everything back. It just filters what is actually shown in the view. So that's really useful. I can also filter out file system activity, network activity, process and thread activity. Maybe I just want to see process and thread activity, and it shows DLLs being loaded in. So these are the DLLs being loaded into that process I started, et cetera. By default, it hides the profiling events. Let me show that really quickly. I'm going to hide all these things and go into profiling events. Once per second, Process Monitor will generate its own diagnostic events, it'll enumerate all the processes in the system and capture some information about them, specifically the amount of user time, user CPU time that it has accumulated to that point, and kernel mode time that has been charged to that process as well. The number of private bytes that have been allocated by that process, and the amount of working set, or the amount of physical RAM that is currently dedicated to that process at the time that this event was captured. By default, those are not shown, but they are always captured and they're part of the trace. You can go back and get them later on. Another really cool way to filter events out of the view is to use the crosshairs icon, which is very similar to the one in Process Explorer. When you click on this and drag it, Process Monitor drops to the background, other windows come forward, and then you can drag that over the window of a process that you're interested in. And when you drop this, it sets a new filter and shows you only the events associated with the process that owns the window that you captured. Let me show you that if I bring up the full filter dialog, this shows the entire set of filters, and you can see it added a filter for process identifier is 2640. Okay, and that reduced the number of events down to 782. So now I've got a smaller set to work with. Let me point out, as long as I'm in here, the flexibility of some of the filtering. By default, it filters out a lot of things that you probably don't want to see. Most of the time, when you're diagnosing a problem on a system, you don't care about the activity that Process Monitor itself is responsible for. So by default, Process Monitor will filter out activity belonging to that process. It also filters out the system process, events belonging to the system process, which is stuff initiated in kernel mode. And there are some times when you may want to turn that off. I'll demonstrate that in just a second. A lot of other low-level events involving the page file, events involving MFT, master file table management, are all filtered out, and the profiling events are filtered out as well. You can add additional filters here very easily. You have a whole bunch of event attributes that you can pick from, and relations that you can apply it to. So, for example, you can say, I'm interested only in the events where the path contains FFV, and then include that. You can include or exclude events based on these criteria. If I add this particular criteria where the path contains FFV, that reduces it down a whole lot. Another thing you can do, which is a fairly recent addition to Process Monitor, is you can temporarily add or remove things from the filter without permanently removing them. So I can just uncheck this box and temporarily put everything back, but then very easily go back in and put that filter back in. You can remove items by double-clicking them or selecting it and then clicking Remove, and it removes it from the list. So those are some really useful ways. Actually, I'm going to take this opportunity to show you where the system process, filtering of the system process, might be something you may want to remove. Let me go over to this 64-bit system, and I've got Process Monitor ready to go with a path contains demo test. I've created a folder in the file system called demo test. And so it's only going to show me events. Now, it's going to capture all the events that are happening, but it's only going to show me the ones that contain demo test in the path. So let me start that up. And I'm going to go back over to my other system, and I'm going to do dir win7 x64 VM, that's the other machine, $C demo test. Okay, I have now accessed that folder on the other system. Let's go over and look at that system, and we see nothing appearing in Process Monitor. And that's because anything going through SMB, through file shares, there's no process associated with that. That's all happening in kernel mode. So if I come in here and remove the filter for system process, those events start showing up. And if I double-click here and look at the call stack, I can see this is all kernel mode stuff. NTOS kernel calling into serve2.sys, and that's what's happening here. As long as I've got this dialog up, let me show you an additional feature here. You can copy this, click Copy All, and it copies the call stack into tab delimited text, which you can then paste into email or notepad file or Word document or, I don't know, Paint. I guess you can't copy text into Paint. And then send it to someone for analysis. Okay, so let's go back to analyzing the problem I had where I got this access denied here. So how do I filter down for that? You could look for, specifically for result equals access denied. I don't do it that way. The way I do it is, rather than look for a specific known problem, I filter out the things I know are not a problem. Because maybe it's access denied, but maybe the error message was misleading. Maybe it's actually a sharing violation or invalid device request, but the application is telling me something like access denied. So what I do is I filter out the things that I know are not problems. So I filter out success, for example. A quick way to do that is you can right-click on any column and row on that text, and the context menu gives you the ability to set a filter including that particular value or excluding that particular value or highlighting it. You can also come down here and include the process name, image path, et cetera, the other visible attributes, and filter them out that way. But this is a quick way because this tells you the specific value in that attribute, and you can filter directly on it. So if I exclude success, I get far fewer events showing. That just excluded a whole bunch. I'm down to 222. End of file, I know that's not going to be a problem. That means that the process was accessing something, reading through a file or a directory or something until it got to the end. Typically not a problem, so I'm going to filter that out. File locked with only readers is not sure when that would ever be interesting. Reparse. Okay, so here it is, access. Can you see that in the back? I'm going to use Zoom It here. Zoom It's not quite as quick inside these remote desktop sessions like I have here. But, okay, this is something accessing HKey local machine system current control set, control safe boot option, and it's giving me a reparse. What a reparse is it says, yes, the file system, the registry or whatever has that object, but it's actually in this other location. And so then what you would see in the next event, if I hadn't filtered out the successes, is you would see it going to control set 001 or control set 002, which is the actual location. Current control set is really just an alias that's built dynamically to identify that. So I can typically remove reparse, although with UAC file and registry virtualization, you'll see reparse events when a process is trying to write to a protected area of the file system, it gets redirected to the user's virtual store. Did any of you come? I know all of you didn't come to my session the other day because hardly anyone was there. You would have seen it demoed, so next time you'll come to my sessions. I'm going to exclude reparse events. Name not found. In this case, I'm pretty sure that's not going to be a problem, although if you're looking for failure to load a DLL, looking for a DLL and not finding it, DLL load errors, name not found might be of interest at that point. Fast I/O disallowed is typically not going to be interesting. That's a very low-level operation or result that I've never seen actually be interesting anywhere. No more entries. It's enumerating values in a registry key, and it came to the end of the list. That's not interesting. Buffer overflow. How many people think that sounds really interesting? By applause. Does that sound scary? How many of you have seen buffer overflow in a process monitor output and thought, I'm in trouble? By applause, anybody? Oh, good. Okay. Buffer overflow, in this case, does not mean that someone is attacking you and getting arbitrary code to run on your system. What buffer overflow is the process is requesting data from typically the registry and saying, here's a buffer of maybe 32 bytes. Put the data in this buffer. And the buffer overflow result says, I have the data, but it's larger than that. It would overflow the buffer if I were to copy it in there. So typically what you'll see in a process trace is immediately after the buffer overflow event, you would see a success event where it requested the same data, but this time with a larger buffer. So I'm going to filter that out because that's not going to be interesting. And now I've got one event left, and that's this access denied. And I can look here and see that it is trying to access this config.dat with requesting permission to delete. In this case, it's actually a rename. I used this in the demo the other day. So that filters things down pretty darn well. You can also use copy all here on this tab, as well as the process tab, and copy that into something that you can take with you. So any questions about filtering data? Oh, let me show one more interesting tip here. I'm going to reset the filter by pressing Control-R, put everything back in. And what I want to show you is a way to filter on a time range in a very quick and easy way. So I could come in here and right-click on something and then exclude or include just that time, but that's typically not what I want. Let's say I want to capture everything throughout the system, all processes, from the start of this demo application until the access denied, but nothing past that point. So I could go in, I could find the beginning of that process, when that process started, and the fastest way to do that is to open up the process tree. And the process tree will show you every process and the parent-child relationships of all the processes that had anything going on that went into this trace, including processes that have exited. The ones that have exited are shown with a dimmed icon. I'm going to scroll down. I'm going to find processes. Where is This is interesting. Did anybody see the process I'm looking for? There it is. Oh, they're all out of order. Okay. Okay, so I find that process in the tree. I click Go to Event, and it takes me to the first event in the trace belonging to that process. So this is the time I want to start looking at events. I want to exclude everything that came before it. So I could look at this time and go into the filter dialog and very carefully type that value, or, because I'll probably get it wrong, here's what I'm going to do. Just for a moment, I'm going to right-click and exclude that specific value. And then I'm going to go find the last event. I'm going to use Control-F and look for access denied, and I'm going to see lots of them here. Find the last one. Here is the access denied belonging to this. I'm going to specifically exclude this event. Okay, now I've excluded 2 events out of the entire thing. Not interesting. Go into the filter dialog, find the first date and time. This is the earlier one. I'm going to double-click that to remove it from this list, bring it up to the edit area up here, and say date and time less than this time, exclude, add that. Take the other one, double-click it, edit that. More than this time, add that. Wait, exclude that, right. So now I'm excluding everything before the first event and after the last event that I'm interested in. Click, and now the first event in the list is process start, and the last event is the access denied. And I've got all the other system activity that's in there. Is that a useful tip for anybody? Okay, good. Other important things you can do with Process Monitor, saving events. Click the Save button, and you can save all the events in the trace, whether they're filtered or not. Just the ones shown using the current filter, and you can choose to include or exclude the artificial profiling events. Or just highlighted events. I'm not going to go into highlighting because I won't have time for PsExec if I do. The file formats, the one you typically want to use is the native Process Monitor format. This captures all the data, all the process, the call stacks, Everything that you can see here, it captures that with full fidelity so you can bring it back on another system. The CSVs and the XML formats might be valuable if you want to do some data processing on those results. Let's see. Boot logging. I do want to show boot logging. So options enable boot logging. Process Monitor is configured to log activity during the next boot. Process Monitor can generate profiling events that capture the state of all running activities, et cetera, et cetera. Click OK and close Process Monitor and get rid of this thing. I've now configured it for boot time logging. And to show exactly where that's coming in, I'm going to run another sysinternals utility called load order, which is an ancient sysinternals utility. Hasn't been updated since 2000. But what this does is it goes through and enumerates all the drivers in the order that they're going to load when Windows starts up. And you can see here, this is Process Monitor right here, very, very early in the boot cycle. The Process Monitor driver gets loaded and starts capturing data and writing it to procmon.pmb in the Windows folder. So it's there before most other critical system drivers are even present. So I'm not going to bore you with rebooting. What I'm going to do is, I'm like Julia Child. I've got this thing, one oven here where I just put it into the oven, the other oven here. I pull it out. Now I run Process Monitor again. When Process Monitor starts up and it finds that that boot trace file is there, okay, here's one thing also. Whenever Process Monitor has been started, has had a filter applied, the next time you bring up Process Monitor, it will ask you, do you want to continue using that filter? You can get by that by using the /quiet option, and then it'll bypass that. I'm going to reset this. Okay, it finds, hey, a log of boot time activity was created by a previous instance. Do you want to save that collected data now? You say yes, and then you tell it where. I'm going to put it in the root of C because I'm running as admin, because I do that. Bootlog.pml. And it's going to take that PMB file and convert it into the PML format. The PML format is different from the PMB. The PMB is a little more resilient to system crashes and things like that. A PML file, when you're doing ordinary logging with Process Monitor needs to shut down cleanly. If you terminate Process Monitor while it's capturing data, it will not be able to put the final bits into that PML file, and you won't be able to get a good data out of it. I'm going to go ahead and enable advanced output, and what that does is it sets the filter to basically nothing. So now I can see all the system activity. I can see Process Monitor driver being loaded. I can see the kernel executable image being loaded, the HAL being loaded in, et cetera, et cetera. So this can give you a lot of information about what happened on your system prior to your being able to run Process Monitor. Okay, I'm going to switch over now, in the interest of time, and talk about PSExec. How many of you have used PSExec? Okay. The top features of PSExec are that you can execute arbitrary processes on a remote computer. You can redirect console I/O, and I'll demonstrate that, which basically allows you to remote enable console applications. And you can execute processes as local system. The syntax on this, as you can see on the slide, is you specify optionally remote computer or computers, where you can specify one or more. \\* says every computer I can access, or you can supply a list of target computers in a file using the ampersand, or the @ rather. You can use alternate credentials. If you're not currently running as admin on the remote machine, you can specify alternate credentials. And there's some cases where you need to use alternate credentials. If you enter -P, you can enter -P on the command line and enter the password. If you don't, it will prompt you and not echo it, so you can type the password in without it appearing on your screen. Now, when you use PSExec, all the other PS tools, PSInfo, et cetera, you can use alternate credentials. It uses Windows authentication to authenticate to the remote machine. And so it's using secure protocols that don't expose the password on the network. With PSExec, it's a little bit different because the password's being used twice, or the credentials are being used twice. First, it's used to authenticate to the remote computer and install and configure a service on that system, which it can then use to perform actions on that system. It then needs to create a new logon representing the credentials you provided to create a new logon session. Why would you need to do that? Now, that part there, it's number 2 that actually can put the credentials on the wire, the password on the wire, where someone intercepting network traffic can see it in the clear. So just be aware of that. Use IPsec if need be. You do need alternate credentials when, like I said, the account you're using is not admin on the remote system, or when you're going to start something on the remote system and it needs to access yet another computer somewhere. Because if you were just to use normal Windows authentication, unless you've got delegation enabled and turned on and configured, you're not going to be able to go from that system to yet another system. And finally, if you want to have a process display remote, or rather interactive, appear on an interactive desktop on the remote system, you need to have a fresh logon to do that. So that's why you would need to use the alternate credentials. This eye chart you can go through at your leisure, or we can go over it in detail now. We'll skip some of it. Useful options with PSExec, if you use -D, that says don't wait for the target process to exit before returning control. I'll demonstrate that in a second. -S is the one that says run it as local system. -I says run it as on an interactive desktop. So let me do some quick demo for that. Okay, PSExec. Like I said, you can run things as local system. You need to be running as admin in order to do that. You can't get there from a standard user prompt. So I'm doing this from an admin command prompt. If I run PSExec -S CMD, I'm now running something as local system. If I do who am I, I'm running as local system in a remote console, running on a non-interactive desktop, but this is remoting that console UI. I can do it interactively, like this, and get a fresh console window running as local system. From here, I could also run regedit, or I could just run that directly from here. Everyone's favorite trick to do to get into this is better than using the @ command to get something running as local system. So you can go play around in deep, dark areas of the registry where you're not supposed to go. Okay. To run stuff on a remote system, 7x64 VM, I want to run, say, ipconfig and redirect that output back to me. Okay. It ran ipconfig on the remote system and redirected the console output back to me. Now, let's say I want to redirect that to a file on the remote system. Okay? You would think, okay, I could do it this way, c:\ipconfig.txt. That won't work. What that's going to, here's what I really want to do is run the command ipconfig greater than C ipconfig.txt on the remote system and get that text file on the C drive of the remote system. This won't do that because this greater than is going to redirect the output of PSExec locally. So what you need to do is escape that, so that becomes part of the command, and the command processor doesn't capture that immediately. But the other problem with that is ipconfig, if you pass in that parameter to ipconfig, it won't know what to do with it. That redirection belongs to the command processor. It's cmd.exe that knows what to do with that. So what you need to do is do cmd/c ipconfig redirect that. Let's see if I got that demo right. Okay, CMD exited on the remote system with error code 0. And if I go to the remote system, there's the file I just created. Okay. Okay, I'm going to go back and show some slides because I've actually got some really useful stuff on the slides which you'll want to work with later on. A couple things about using psexec. If you're using psexec to run a sysinternals utility on a remote machine, okay, all the sysinternals utilities, because of our LCA, our legal and whatever CA stands for, forced Mark and Bryce to display a dialog whenever anyone's using a utility for the first time, saying, you must agree to our terms, the EULA dialog. You can bypass that with the /accept EULA and get past that. But if you're doing it on a remote machine and you don't use accept EULA, what's going to happen is on a remote system, on a non-interactive desktop, some sysinternals utility is going to be sitting there waiting for someone to click on a button, and it's never going to happen, so it's just going to hang. So pass in accept EULA whenever you're using psexec to run a sysinternals utility remotely. Things you can't do in a redirected console. If you try to do a CLS, when you're doing a redirected console, the place where the process is actually running has no idea where it is on the screen or what color is there or anything like that. It's just straight text input and output. So things like CLS and more and text coloring and tab completion do not work when you have redirected console I/O. PowerShell v1 also will not work. You can't redirect that in a console. v2 does work. Here's a useful tip. Running process monitor past logoff using psexec. Let's say you want to analyze what's happening when a user is logging off. Okay, well, process monitor is going to, if it's in the interactive session, it's going to get shut down as part of the user's log off. So one way to capture that information is to run it non-interactively so that it's not in a session that gets shut down when the user logs off. In order to do this, you need to specify a backing file. Okay? Ordinarily, by default, when Process Monitor runs, it just writes all its data into its own virtual memory. You can specify a backing file and say, write it to this other file location instead. When you're doing this and running it in a non-interactive context, there must not be any user interaction. So always specify accept EULA and also specify /quiet so that the filter dialog doesn't hang you up. So here's the syntax. psexec, run it as local system in a non-interactive context. -D says allow psexec to return control. psexec can exit as soon as process monitor is started. Accept EULA /quiet and specify the backing file. Then to stop that, you have to terminate it in the same way. Remember I said you can't terminate, or you can't kill process monitor and get useful data from it. So using the same syntax, psexec /-s-d procmon accept EULA /terminate. So it's going to run an instance of process monitor in the same non-interactive desktop with a /terminate, which says look for existing instances of process monitor in that desktop session and send it a message saying cleanly shut yourself down. Okay, additional resources. Mark's blog is a great place for case of the unexplained information on troubleshooting and diagnostics and learning cool new ways to waste lots and lots of time playing with Windows. Some blog posts and utilities that I've written, because as long as I'm up here, I may as well advertise a little bit. I do a lot of work with federal desktop core configuration with the federal government, and I've written utilities that are useful for local group policy management, security zone settings, and things like that. Mark's session is coming up. later today, and my case of the app compat bug is probably available on a recording somewhere. So we're just about ending right on time. Do we have any questions? If anybody has any questions about sysinternal's utilities, come up to one of the microphones, please, and let's hear it. Is that? Oh, yes. Let me see. We have... Yes, you can win things by filling out evaluations for this session. And I need to remind you that the higher the eval scores you give us, the better your chances of winning.